Imagine you are opening an e-commerce application. The home screen loads, and behind the scene, your phone is making four separate API calls: profile, cart, reviews, and inventory. Four round trips over a slow mobile network, one by one. That's not a feature, that's a design problem. And today we are going to fix it. Here's the world we live in with microservices. You have a product page, it needs data from four different services. In a native implementation, the client calls each one directly. That means four separate HTTP round trips over a slow, flaky mobile network. And it compounds. More call means higher latency. Higher latency means battery drain. Battery drain means a frustrated user. Worse, your client is now tightly coupled to every service endpoint. You move a service, you update every client. That's fragile. And that's exactly the anti-pattern we need to solve. So what is a gateway aggregation pattern? A gateway sits between your client and your backend services. The client sends one request, the gateway fans out to multiple services in parallel. It collects all the responses and it assembles them into a single payload, which it returns to the client. One request in, many services queried. One response is out, that's it. Look at the diagram here. The client talks to exactly one thing, the gateway. The gateway handles the complexity of talking to service A, service B, and C. The client never knows these services even exist. This is the core idea: push complexity to the edge, keep clients thin. Let's make this concrete. Without aggregation, your client makes 6 separate round trips to services. With gateway aggregation pattern, it makes one aggregated call. That's the difference. But it's not just about the count of requests. First, lower latency. Because the gateway calls services in parallel, not one by one, you collapse the total wait time. Second, lighter clients. The aggregation logic lives on the server, not on the device. Your app code gets simpler. Third, less coupling. The client knows only one endpoint. If services move or change, only the gateway needs updating. And fourth, central control. One place to add, retire, timeout, caching, and circuit breakers. One place to own resilience. Let's put it all together. Step 1. Spot the chatty calls. Look for screens or endpoints that hit 3 or more services. That's your candidate. Second, add an aggregator. Place a gateway or a dedicated endpoint between the client and those services. Step 3. Fan out in parallel. Call every downstream service asynchronously with individual timeouts on each call. Step 4. Merge and degrade gracefully. Combine the results into a single DTO. If one service fails, return partial result rather than 500. And last, and step 5, add resilience. Layer in caching, retires, and circuit breaker, so a flaky downstream service never breaks the whole response. Let's look at real C# code. This is using API ASP.NET minimal APIs, which is perfect for a lightweight gateway endpoints. We have one route, products/ID. It receives 3 injected clients, a profile client, a review client, and a stock client. And here's the key part. We fire all 3 calls at the same time, not one after the another. In parallel, we use task.whenAll to wait for all of them simultaneously. So if each service takes 200 milliseconds, the total wait is 200 milliseconds, not 600. Then we combine the result into a single product VDTO, details, review, and stock status, and return it as one clean response. Key takeaway from the code: the client gets one response. It has no idea there were three services involved. That's the beauty of this pattern. Complexity on the server, simplicity for the client. And this is just the foundation. You can add timeout wrappers, fallback values, and caching on top of this exact solution. Let's bring this to life. Think of any major e-commerce app: Amazon, Flipkart, Myntra. When you open a product page on your phone, what does that screen need? Product details and images, live price and inventory, rating and reviews, recommendations, and your cart badge. How many times you have? How many items you have? That's five separate pieces of data from five different services. Without aggregation, your app makes five network calls. On a 4G connection in a crowded area, that could mean 2 seconds of loading time and a user who bounces. With gateway aggregation, you expose a single endpoint. One call, the gateway handles the fan out. The app gets everything it needs in one shot. Faster loads, less battery consumptions, and simpler app code. This is not theoretical. This is how product teams at scale actually build. Now let's prep you for the interview room. 3 questions that actually come up when you are interviewing for senior or architect role. Question 1. What is the difference between gateway aggregation and an API gateway? An API gateway routes requests and handles cross-cutting concerns like authentication, rate limiting, and logging. Aggregation is a specific capability, merging multiple backend responses into one. Most API gateways can do aggregation, but aggregation is not the same thing as the gateway itself. Question 2. How is it different from backend for frontend pattern? A BFF or backend for frontend is gateway tailored to a specific client type, like a mobile BFF that knows exactly what the mobile app needs. BFFs frequently use aggregation as their main technique. Aggregation is the technique. BFF is the deployment shape. Question 3. What if one backend service is slow or goes down? Call services in parallel with pre-call timeouts. If one times out, return partial result with a default or null value for that section. Add circuit breakers so a failing service doesn't drag down the whole response. Degrade gracefully. Never fail completely because one dependency is slow. Let's wrap it up. The problem: chatty clients making too many round trips, too many services. The pattern: a gateway fans out in parallel and returns a single aggregated response. The wins: lower latency, looser coupling, lighter clients. And watch out for the gateway becoming a bottleneck or a single point of failure. Scale it, add resilience. And the one thing to remember from this entire deck: aggregate at the edge, keep clients thin. Next up, gateway offloading, where we look at what else you can push off the client and onto the gateway. Follow along so you don't miss out. I am Varun. See you in the next one.